Hello students, today's topic beta function. So what is the use of beta function? To evaluate integrals. So what type of integrals? So that integral contains bracket, and that bracket contains either addition or subtraction of two terms into x raised to n dx. That integral have some limits, lower limit, upper limit. So you can evaluate such type of integrals by using beta function. So what is the definition? So definition of beta function is, there are two definitions. First one for addition, another one for subtraction. So first definition, beta mn is integral from 0 to 1 t raised to m minus 1 into 1 minus t raised to n minus 1 dt. For example, suppose integral from 0 to 1 t raised to 3 into 1 minus t raised to 4 dt. Then its answer in terms of beta is, add 1 in power of t, then we get first number, add 1 in power of that bracket, so power is 4, so 4 plus 1 is 5. So we'll see one more example, 0 to 1 t raised to n by 2 into 1 minus t raised to m dt. Then its answer is, you have to add 1 in power of t, so n by 2 plus 1, add 1 in power of 1 minus t, so its answer is m plus 1. So this is the definition of beta function. If bracket contains minus, then we use this definition. If bracket contains addition, then you have to use this definition. Integral from 0 to infinity, t raised to m minus 1 upon 1 plus t raised to m plus n dt. So that bracket with minus sign in numerator, bracket with plus sign should be in denominator. For example, 0 to infinity, t raised to 3 upon 1 plus t raised to 10 dt. Then you can write down this in terms of beta. Add 1 in this power of numerator, so then we get 4. Subtract that number from power of denominator, so 10 minus 4. So this is the second definition of beta function. Then we'll see one more example, 0 to infinity, t raised to 2 upon 1 plus t raised to 6, 1 plus t raised to 6 dt. So beta of, add 1 in power of t, so we get 3. Subtract that number from power of denominator, 6 minus 3. So these are the two definitions. Then properties of beta function. Properties of beta function. So first property, you can write down beta mn as beta nm. That means, suppose beta 3 comma 5 is same as beta 5 comma 3. This is first property. Then second property, you can convert beta into gamma. Beta mn is gamma m into gamma n upon gamma of m plus n. For example, beta of 2 comma 3, so its answer is gamma 2 into gamma 3 upon gamma 2 plus 3 is 5. You can simplify this. gamma 2 is 1 factorial, gamma 3 is 2 factorial, gamma 5 is 4 factorial. 1 factorial is 1, 2 factorial is 2, 4 factorial is 24. So its answer is 1 by 12. This is second property. Then one more property, third property, 0 to pi by 2 sin raised to p theta into cos raised to q theta d theta. So you can write down such type of trigonometric integral in terms of beta. So 1 by 2 beta of p plus 1 upon 2 comma q plus 1 upon 2. For example, 0 to pi by 2 sin raised to 3 theta cos raised to 5 theta d theta equals to 1 by 2 beta of, what is the power of sin? 3. So 3 plus 1 upon 2, power of cos is 5. So 5 plus 1 upon 2. So this is 1 by 2 beta of 4 by 2 comma 6 by 2. That is 1 by 2 beta of 2 comma 3. Then you can simplify that beta by using gamma function. So these are the three properties of beta function. Now we will solve some numericals over beta function. We evaluate some integrals by using beta function. So this is the first problem. Evaluate integral from 0 to 1 x cube into bracket 1 minus root x bracket raised to 4 dx. So first observation, this integral contains bracket. This integral contains bracket. So you can use beta function. But this integral is not in standard form of beta function. So you have to convert that integral into standard form of beta function, and then you can write down answer in terms of beta, and then using calculator you can find final answer. So first step, say that integral as I 0 to 1 x cube into 1 minus root x raised to 4 dx. Then this integral contains bracket, and that inside the bracket 1 minus root x. So you have to use first definition of beta function. What is the substitution? Substitution is second term of bracket upon first term equals to t. So in beta function there are two substitutions. If integral contains one bracket, then substitution is second term of bracket upon first term. If integral contains two brackets, then another substitution. So for this first question, substitution is root x upon 1 equals to t. For this second question, what is the substitution? X square upon 1 equals to t. But this third integral, third problem contains two brackets. If two brackets, then substitution is x minus lower limit equals to upper limit minus lower limit into t. That means in beta function there are only two substitutions. First one is single bracket and another one is two brackets. If single bracket, then second term of that bracket upon first term equals to t. If integral contains two brackets, then you have to use this substitution, x minus lower limit equals to upper limit minus lower limit into t. Now we will simplify this. So root x equals to t, squaring both sides, so we get x equals to t square. So after getting x, we have to differentiate with respect to t. Differentiate with respect to t. So dx by dt, what is the derivative of t square? 2 into t raised to 2 minus 1. So dx equals to 2t dt. So we get dx. Then you have to determine limits. So using relation between t and x, you can find limits. So t equals to root x. Lower limit t equals to, what is the lower limit of x? 0. So replace this x by 0. Square root of 0 is 0. Upper limit t equals to, replace this x by upper limit. So what is the upper limit of given integral? 1. So square root of 1 is 1. Then substitute this lower limit, upper limit, dx, x and root x in equation 1. Then that equation 1 becomes I equals to, what are the limits? 0 to 1, x cube, but x is t square. So t square cube into bracket 1 minus root x, but root x is t. So 1 minus t bracket raised to 4 into dx. What is the value of dx? 2t dt. So 2t dt. Now this 2 is constant, you can write down outside the integral. T square raised to 3. So by law of indices, 2 into 3, 6. So t raised to 6. 1 minus t raised to 4 into t dt. Now this t and this t raised to 6, base same. So you have to take addition of these two powers. 6 plus 1 is 7. So 2 into 0 to 1, t raised to 7, 1 minus t raised to 4 dt. Now this is in standard form of beta integral. So 2 into beta of 7 plus 1, 8, 4 plus 1, 5. So its answer is 2 into gamma of 8 into gamma of 5 upon gamma of 8 plus 5 is 13. So this is 2 into gamma 8 means 7 factorial, gamma 5 means 4 factorial, gamma 13 means 12 factorial. So you have to type this in calculator, then we get final answer. So this is first problem. So in beta function, we have to use two substitutions. If bracket integral contains single bracket, then substitution is second term upon first term equals to t. If integral contains two brackets, then you have to use this substitution.